Hey guys, welcome to today's lesson. Today we are looking at bearings with right angle trigonometry. Again, you probably have done this in year 9, so it should be too new, but certainly those in Mr. Finch's class may not have looked at this before, and it's probably the more complex question. So when we're talking about a normal year 9 5.3 examination, you will tend to see bearings as the number one hard question, and even year 10, to be honest with you, as well. So a lot of people will struggle because we can't get the diagram out, and that's the most important thing. Get the diagram out, then everything else unravels, like we saw with those 2D and 3D application questions. Two things I want to talk about before we actually look at a question is types of bearings. So we have really, in my view, two types of bearings. We have what we call as a compass bearing, okay, and then we have what we probably use more often than not, and that's what we call a true north bearing. So you may remember these from previous years. So what's the difference? Okay, so I'm going to give you two different bearings. For example, I'm going to give you south 30 degrees east, and then I'm going to give you a bearing of 150 degrees, capital T. So you can see straight away by looking at these two different bearings that they have a different format, okay? For the compass bearing, we always have a north-south direction, a vertical direction first of all, okay? So it might say, in this case, south 30 degrees east. It could even say something like north 20 degrees west. So it's telling us that we're going south or north first, and then how far east or how far west. So if we look at that first one, I'm going to start off, I always call these crosshairs, okay? It's always important. That's my northeast, southwest kind of crosshair bearing. So in this case, if we're going south first, we always start at that vertex there, okay? We're going to go south, and then we go 30 degrees to the east, which means we have 30 degrees sitting inside that little part there. And let's call that point A, okay? We'll call that point A. So again, it's telling us we're going south first, and then we're heading at 30 degrees east. Now, of course, if I went, the second bearing I gave, I crossed out, is north 20 degrees west. You go north, and then you go 20 degrees to the west, okay? Making sure you know your east and west as left and right, etc. That's pretty much it for a compass bearing. Now, if we talk about a true north bearing, you know, again, we start with the same setup, okay? My little north, southeast, west crosshair. This case gives you simply, we call it a true north because we always start from north, which means we always kind of stand that vertex and we look to that north direction. And then it tells us how far around we have to go in total. Now this one says a total of 150 degrees, which means of course we're going to turn the first quadrant, which is 90, and we're going to go a further 60 degrees inside here. And that, in case, will give me my A bearing. We'll call that A. Now, what you might notice is, in fact, those two bearings are exactly the same, because if we look at the complementary angle inside here, that's 30 degrees, and vice versa, the complementary angle in the first example, okay, that was also 60 degrees. So you can see that a south 30 degrees east is the same as 150 degrees true north. Now, what has to happen for a true north bearing? Well, it needs to be a 3-figure bearing. That's really important, okay? If it's less than 90 degrees, chuck a 0. For example, 057 degrees, capital T. You should put the capital T there. You don't often get marked down for not putting it there, but let's not chance that. Let's have the T in there. And again, that simply means true north. So it's a 3-figure bearing. I'm going to write that down, a 3-figure bearing. Whereas your compass bearing, okay, gives that north-south first of all, and then tells me east or west. That's pretty much it. So when we're doing questions with right angle trigonometry, and later on with non-right angle trigonometry, okay, it's all about coming up with these diagrams and then looking at the triangle. So for example, if I look at that, well, they're both the same diagram, the second diagram, you know, we might be asked about how far south, or perhaps how far east we are, giving one other length. So it's again coming up with that diagram first and then applying it to using trigonometry. I've just grabbed a couple of questions out of the textbook, gents, so don't obviously do these ones for work samples. Question 5 has given us a diagram, so harder bearings, not even harder bearings, but maybe the easier questions. they might actually provide you with a diagram. So in this case, it says, for this simple map, find the following correct to one decimal place. How far west is point A from O, and how far south is point A from O? So my question, view, this isn't really a bearings question per se, because they've just given you a diagram. We've just got a right angle triangle. Look at that. That's all we've got, a nice right angle triangle upside down. We've got 65 degrees sitting inside there. Okay, we're given that 4 kilometers, and they're asking us to find how far west is it, and then how far south is it. So they're asking us to find those different amounts. Now, for part A, we're going to have to use trigonometry, of course. All right, again, just a normal trig question, finding a side. So if it says how far west, so we're looking for the W and the 4 kilometers and the 65 degrees. Now, remember our rules. First of all, label. Okay, we have our adjacent side, we have our hypotenuse side, which means we, of course, are using cos. So cos 65 degrees is equal to my adjacent, in this case it's W, whatever letter you want to have it, over 4. So it's just a simple question, 4 times cos 65. Now it says, in this instance, correct to one decimal place, so we know what the rounding is. So I'm going to type in 4 times cos 65. Okay, nothing really too challenging there. Okay, we get 1.69047 dot dot dot. You know, I like to write the answer out. 1.7 kilometers in this instance, and that's my answer. Now, you have another option, or 2 options, I guess, to then answer part B, because part B says how far south is it? Now, what you've actually got there is a right angle triangle, and you know 2 sides, so technically speaking, I can just use Pythagoras, albeit I've given the longer side, so we're finding the shorter side. So to find S, we can say 4 squared, take away, well, 1.69047 dot 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 squared, okay? Remembering, if I'm going to do this way, I'm going to need to use the exact number, okay? My answer button will probably be better. And also remembering that we are given what S squared is. So I'm going to type that in. I'm going to type 4 squared. I'm going to use my answer button minus my answer squared, okay, equals, I get 13.142, okay, and I'm going to square root my answer. So square root my answer, we come up with 3.62523, which means S equals 3.6 kilometers. And that's your first option to do that second question. Of course, you may have said, well, hold on, can't I just use trigonometry? And absolutely you could. Okay, in this instance, in regard to 65 though, using S and 4, which means you're using the opposite and the hypotenuse, which means now you're using sine. So sine 65 equals S over 4. So S equals 4 times sine 65. And then I can simply type in on my calculator 4 times sine 65 in this case, and you get 3.625, the exact same answer, 3.6 kilometers. So you might figure out that the second way using trigonometry is way quicker. You're not having to use exact numbers, etc., and use your answer button, but certainly it's a quick way to do it. But both ways are fine, and so you can use the Pythagoras, or you can use trigonometry. It's up to you what you do. But again, for me, not really a bearings question because it's just a diagram. Of course, what they may have said to you is that hiker A, for example, has left base camp of O, and he's walked on a bearing of. Now, compass bearing, what do you reckon it would be if I had to walk that 65 degrees inside there? Well, think if that's 65 inside there, that little bit inside there, of course, would be what? Be 25 degrees, wouldn't it? So you'd be saying something like south 25 degrees west. That would be your compass bearing. Okay, so going south another 25 degrees. Or you could say for a 3-figure bearing, a true north bearing, 180 plus the 25. So 180 plus 25 equals 205 degrees, capital T. So they could have said something like that little story where the hiker walked to point A from O on one of those 2 bearings. So they actually asked you to come up with that diagram. That's where it gets a little bit more challenging. But apart from that, you can see once you have the diagram, it's just the same kind of stuff that we've been doing. Now, if we look at question 12, please feel free to pause this and have a crack at the question. This is probably more of that bearing style of question where you don't have a diagram, you have to come up with your own one. Make the diagram nice and clear. Usually if you've got a written booklet, we say use 1/3 of the booklet, make it nice and big so you can really see it clearly, okay? Pause it and have a crack and see how you go. All right, how'd you go? A military tank maneuvers 13.5 kilometers from point A on a bearing of 42 degrees to point B. Well, I don't have a starting point, but I do know if I'm going on a bearing of 42 degrees, I'm kind of going of a northeasterly direction. Now that's important because, if I start up here, right, from my crosshair, and all of a sudden I want to draw up, I've run out of room. So that's a bit annoying, right? So I always just double check, it can be safe to kind of give yourself a bit of room all around, but just have a look at your question and see, am I going up or down? And it can help me draw my diagram. But this is my point A, I'm going to label it. And it says we're going on a bearing of 42 degrees to point B. So I'm going to draw my nice angle there. One thing with bearings, you'll notice every time I get to a new point, I do a little crosshair. Really important. I think it really helps a question, and I'll show you a little bit why. Making sure, of course, that we are labeling. Okay, that's 13.5 kilometers. Okay, now it doesn't have to be to scale either. I always just do like pretty much right in the middle of it. As long as you put your 42 degrees inside here, that's all that matters. Okay, it doesn't matter that it's not to scale. If that's 42, of course, well, this will make this 48 degrees. I always put as much information as I possibly can in. Okay, from point B, how far due south must the tank travel to be at a point that is due east of point A? Now this is important, I haven't spoken about this. Due east and due west, or due north and due south means exactly east and exactly west, okay? Or exactly south and exactly north. So that's a really nice word to use, due. So what this is asking me, of course, is how far due south is it? It's asking me about this measurement here. So you can see I've just constructed a nice right angled triangle. One thing I've noted, and this won't help you so much with right angle trig, but non-right angles, remember we actually have, and I'll just highlight it here, we have alternate angles inside there as well, which means that these two angles inside here are equal. Likewise, the 248s up there are equal. And later on, that might help you, okay? But in this case, it doesn't really help you because you've got an angle in your triangle anyway. Let's call this, we'll call this S, okay? How far due south is it to be a point A? So to the nearest meter. That's all it's going to be. So what you can see here, I'll just draw it in blue. This is pretty much your right angled triangle. Most of you will have the 48 inside there, which is nice and easy. You can use the 42 as well, of course, inside the triangle. I'm going to label my sides. Okay, of course, that's my opposite side. I've been given my hypotenuse side. So in this instance, we're going to be using sine. So sine 48 equals my opposite over my hypotenuse of 13.5. It's a nice question because it's just a straight multiplication. Times sine 48. S equals, I'm going to type my calculator, and that's as hard as it gets. Like, it's not that difficult, but of course, it's all about how you get your diagram. Some of the questions, particularly for non-right angled trig later on, they're a little bit hairy in terms of actually drawing the diagram. 10.032 dot, 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 but of course, we want to the nearest meter, so the nearest kilometer, 10 kilometers. Oh, actually, no, it wants the nearest meter, doesn't it? Okay, so let's be careful there. So nearest meter, I think there's 1,000 meters in a kilometer. Okay, so 10.032 kilometers. Okay, or 10.03. One of the two. Just make sure you answer the question to correct rounding. Again, not a hard question, gents. That's all it pretty much is. Come up with your diagram first, clearly, of course. See how it's mine. I've got a nice big diagram. And then once you've got that, label your sides as we would normally do. Find the ratio that you're using, apply it, solve it, and then round it correctly. Okay, round it correctly. That's about it. Have a wonderful day.